Hey class, it's Brett Carter, and I'm going to talk to you about a vulnerability assessment that I took place for Chris Campbell Systems. All right, introduction. My group consisted of Chris Campbell, Hunter Young, and myself. I scanned Chris's CentOS 7 server on Tuesday, November 17th at 10:31 p.m., and I scanned his Microsoft server on Thursday, November 19th at 7:34 p.m. His Windows server's IP address is 192.168.6.104. His Linux server IP address is 192.168.6.105. And all this was reformed within the Network Development Group NetLab Plus version 2015.r2.beta.3. And the default gateway is 192.168.6.1, and the net mask was 255.255.255.0. Alright, for scope of the test, I scanned Chris's servers using Nmap on a virtualized Kali 2.0 machine, and I scanned his servers, also scanned his servers using Nessus on a visualized Kali 2.0 machine. His Nmap is an open source tool used for network discovery and security auditing, and its main function is to find ports that are open and active. Nessus is an open source network vulnerability scanner, and its main function is to find vulnerabilities and how to fix them. Application security issues for Windows. There's a medium severity, and this was the DNS server cache snooping remote information disclosure. And I found multiple on Chris's Linux, and they were medium severity, SSL certificate cannot be trusted, medium severity SSL signed certificate, medium severity SSL version 2 and 3 protocol detection, medium severity Microsoft Windows SMB guest account local user access, and medium severity SSL certificate with wrong hostname. Alright, continuing on the vulnerabilities for Linux, there's medium severity SMB signing disabled, medium severity HTTP trace and track methods allowed, medium severity SSL medium strength cipher suits supported, medium severity SSL RC4 cipher suits supported, low severity SSH server CBC mode ciphers enabled, low severity SSH weak MAC algorithms enabled, and low severity SSL certificate chain contains RSA keys less than 2048 bits. Alright, moving into the technical summary. There were 0 issues on Chris's operating systems. Moving into each service, his HTTPS for Windows, Chris used the IIS web server to run both HTTP and HTTPS. He had both ports open and running. HTTP listened on port 80 and HTTPS listened on port 443, and there were no vulnerabilities found for this service. For HTTPS Linux, Chris used the Apache web server to run both HTTP and HTTPS. Chris had both ports open and running. HTTP listed on port 80 and HTTPS listed on port 443. The vulnerabilities found are discussed below. Alright, the recommendations and fixes. There were 0 for his Windows. For Linux, SSL version 2 and 3 protocol detection. This can be fixed by disabling SSL 2.0 and 3.0 by consulting the application documentation, or by using TLS 1.1 or higher. SSL certificate with the wrong username. This can be fixed by changing hostname to the correct one using hostnamectl, and then or you can also create a new certificate with the hostname. Alright, for HTTP, trace track methods allowed. This can be fixed by simply disabling the trace and track methods. SSL medium strength cipher suites supported. This can be fixed by editing the config file and then editing SSL cipher suite to SSL cipher suite high. SSL RC4 cipher suite supported. This can be fixed by following the same steps mentioned above. SSL certificate chain contains RSA keys less than 2048 bits, and this can be fixed by changing RSA key from 2048 bits to a longer key, and then reissued any certificate signed by the old certificate. Alright, POP3 security issues. Windows does not require POP3. For Linux, Chris used the Dovecot web server to run POP3 and POPs. Chris had both ports up and running, and POP3 listens on port 110, POP3S listens on port 995. Vulnerabilities found: SSL certificate cannot be trusted, SSL self-signed certificate, and SSL RC4 cipher suites supported. For the recommendation fixes, were none for Windows. Linux. SSL certificate cannot be trusted. This can be fixed by simply generating a new certificate that allows the proper guidelines for purchasing one that is certified to be trusted. SSL self-signed certificate. This can be fixed by performing the same action by fixing SSL certificate cannot be trusted. SSL RC4 cipher suites supported. This can be fixed by reconfiguring the application to use TLS 1.2 by following these steps. For SMTP security issues, for Windows, Chris used the IS web server to run SMTP. SMTP list is on port 25, and he had it up and running, and there were no vulnerabilities found for this service. For Linux, Chris used the Postfix web server to run SMTP. SMTP listens on port 25, and he had it up and running, and there were no vulnerabilities for this service either. IMAP security issues. For Windows, IMAP is not required. For Linux, Chris used the Dovecot web server to run IMAP and IMAPs. Chris had both ports open and running, and IMAP listens on port 143, and IMAPs listens on port 993. The vulnerabilities found were SSL certificate not be trusted, SSL self-signed certificate, SSL version 2 and 3 protocol detection, SSL certificate with wrong hostname, and SSL RC4 cipher suites supported. Okay, the recommendation and fixes. For Windows, there weren't any. For Linux, all vulnerabilities can be fixed by following these simple steps. Edit config file, and then edit the SSL protocols to equal TLS version 1.2, and then edit the SSL cipher list to equal TLS version 1.2, and then edit the host name using hostname CTL set hostname, and put the name of the host you want it to be. And then you finally save these changes in the config file and restart the service. Samba security issues. For Windows, Samba is not required. For Linux, Chris used the Samba version 3 web server to run Samba. Samba lists on port 139, and he had it up and running. And the vulnerabilities found were that Microsoft Windows SMB guest account, local user access, and SMB signing disabled. Alright, the recommendation fixes. There weren't any for Windows. Linux, Microsoft Windows SMB guest account, local user access. This can be fixed by changing the setting for network access, sharing and security model for local accounts from guest only, local users authenticate as guest, to classic local users authenticate as themselves. And if applicable, disable the guest account. Alright, DNS security issues. For Windows, Chris used the IS web server to run DNS. DNS lists on port 53, and he had it up and running. The vulnerability found was that the DNS server cache snooping remote information disclosure. And for Linux, Chris used the bind web server to run DNS. And DNS lists on port 53 and had it up and running, and there were no vulnerabilities found for this service. Recommendation to fixes for Windows: DNS server cache snooping remote information. This can be solved by either of these three methods. Leave enabled in case the server cannot be reached by untrusted clients. Do not allow public access to DNS servers performing recursion, or if need be, just disable recursion. And for Linux, there weren't any. Alright, Active Directory, security issues. For Windows, Chris used the IS web server to run Active Directory, and Active Directory lists and ports 88, 193, and he had them both up and running, and there were no vulnerabilities found with this service. And for Linux, Active Directory is not required. Alright, LDAP security issues. For Windows, Chris used the IS web server to run LDAP. LDAP lists on port 389, and he had it up and running. There are no vulnerabilities found with this service. And for Linux, Chris used the Open LDAP web server to run LDAP. LDAP lists on port 389, and he had it up and running. And there are no vulnerabilities found in this service either. Alright, database security issues. For Windows, database is not required. And for Linux, Chris used the MySQL web server to run database. Database lists on port 3306, and he had it up and running, and there were no vulnerabilities found on this service. The final service is the SSH, and these security issues for Windows, SSH is not required. For Linux, Chris used the OpenSSH protocol to run SSH. SSH listed on port 22, and he had it up and running. And the vulnerabilities found were SSH server CVC mode ciphers enabled, and SSH weak MAC algorithms enabled. Recommendations and fixes for SSH, none for Windows. For Linux, SSH server CVC mode ciphers enabled and SSH weak MAC algorithms enabled can be fixed by editing the config file and then adding the following and then removing MAC SHMAC-SH1 comma MHMAC-RIPEMD160, and then finally you save the file and restart the service. Here are the vulnerability scans that I took for Chris. The one on the left is the Windows, and the one on the right is Linux. Alright, finally, this is the vulnerability ranking scale. As shown, critical is the highest. Poses a very high threat, needs to be fixed immediately. High, which is 7 to 9. Pose an above average threat and should be fixed as soon as possible. Medium, it's range 4 to 6. Poses a below average threat and needs to be fixed within a few days. Low, it's range from 0 to 3. This poses little or no threat, and action can be taken to fix the threat if need be, but not necessary. And finally, the blue is information, and items are listed for informational reasons and pose 0 threat. Thank you so much for listening to this presentation. This is it.